Because today's the problem is maximum difference between node and its ancestor. So we'll be given a root of a binary tree, and we need to find nodes A and B such that the maximum difference between them it will be the maximum one, and A should also be the ancestor of B, and it is clearly mentioned that we must take absolute difference. Okay, so let us see what is ancestor. Okay, ancestor is nothing but ancestors are all the nodes that we encounter while we are going upwards till root. Okay, like for 4, let us say for 4 we are going up for 2, and then we can also go to 1 in the upward direction, right? So we can consider 2 and 1 as ancestors of 4. Similarly for 5, while we are going upwards we encounter 2 and 1, right? So 2 and 1 will be the ancestors of 5. For 3 there is only one ancestor which is 1, and for 6 we have two ancestors which are 3 and 1, because we encounter them while we are going upwards. Okay, so let us see the given case. It is a given problem, and for this problem the optimal answer was the difference between this 8 and this one. 8 is ancestor of 1 because we can encounter 8 while going upwards, right? So let us see how we can approach this problem. So let us take one graph. I mean, this is not given in question, but let us take a normal graph. Okay. So we need we need to consider three parameters here. Okay. First thing is the minimum value until now, maximum value until now, and maximum difference we obtained until now. Okay. So currently for one we do not have any ancestors, right? So uh, the minimum value till now will be one. The maximum will also be the one, and there are no ancestors, right? So let us take difference as 0. Okay. Now let us go down to 9. When we come to 9, the minimum value will be 1, right? Because 1 is smaller than 9, so 1 remains the same. The maximum value changes to 9 because 9 is greater than previous maximum, which is 1. So it will be 9 here. And then coming to the difference, it was previously 0. Now we can get a difference of 9 minus 1. Maximum minus minimum is 8, right? So we'll get maximum difference as 8 here. This, uh, this will be the reflect here. And coming to 3, 1 is smaller than 3, so minimum remains same. 9 is greater than 3, so maximum also remains the same. So the maximum difference also remains the same, right? We can apply maximum difference between maximum minimum elements. It is clear, right? So then coming to 5. Till now the minimum element of 1 and pi is greater than 1, so 1 doesn't change. Maximum element was 9 previously. So since pi is less than 9, so maximum also remains the same, and the difference also remains the same, right? We do not have any nodes below it, okay, below 5. So we return this maximum difference from here, right? For here, the left side maximum answer for 3 is here. Okay? Now we have to evaluate right side. If right we have 6, 1, previous minimum was 1, 1 is smaller than 6, so minimum remains the same. Maximum was 9, 6 is less than 9, so maximum also remains the same. And the difference will be 8, right? Maximum minus minimum is 8. So uh, here also we do not have any children for 6, right? It is a leap node. So we return this maximum difference to 3. Now for 3 we have two considerations. One answer is 8, and the left subtree returns 8, the right subtree also returns 8, right? So the maximum of both is also 8. So 3 returns 8 to its parent 9, and it returns 8. So left subtree, we have evaluated the left subtree and we got 8, right? Coming to the right subtree, for 13, initially minimum was 1, right? So minimum remains the same because 13 is greater than 1, and maximum element changes because 13 is greater than 1, so it changes, and the absolute difference between both of them is 12. So maximum difference changes here. Coming to this case, the minimum previously was 1, right? So it becomes 0 right now because 0 is less than 1. The maximum remains the same because 13 is greater still, and the maximum difference we obtain is 13, right? It will be 13 here. Coming to its side, 7. 7 is greater than 0, so 0 will remain the same. 7 is also less, 7 is less than 13, maximum also remains the same, right? And the maximum difference still remains 13, which is 13. And 7 is leaf node and it doesn't have any children, right? So in this case, we return 13 to its parent, right? And there are no right children for 0, because so we return 13. And 13 doesn't have any left child, right? So here also we return 13. For root node, now we have two possible answers. For the left circle, the answer was 8, and the right circle, answer is 13, right? So maximum of 8 and 13 is 13. So the answer will return will be 13. Okay, this will be the approach for us, and let us look at the code. This is the code I've written. As I said, initially there are no ancestors for root node, so the minimum and maximum will till now will be the root node only, and after it, just we can iterate. We can update maximum difference by considering difference between maximum value and difference between minimum value, and after that we can update the maximum minimum values, and we can go to left and right. At last, we can return the maximum from the subtrees we obtain from left and right subtrees. And if whenever we encounter none, we return maximum reply, because as I said, 5 doesn't have any nodes. So here we return 8, and 6 also doesn't have any nodes. So here also we return maximum difference. So this code will work perfectly. So this is a solution with this endless time complexity. We encountered, I mean, we iterate over each node exactly once, right? So the time complexity will be on order of n, where n is number of nodes. And let us talk about space. Coming to normal space, we do not take anything, right? We just maintain left and right, left difference, right difference, and all. So we do not create any variables. Uh, but coming to recursion stack space, we store all values of all the nodes, right? So I mean, we store the values returned by all the nodes. So recursion stack space will be order of n. So this is the solution. Thank you. If you have any doubts, please ask in comment section. I will try to help. Thank you.